so we're starting question number 11 of the worksheet forces in motion. Okay, a car travels along a straight road with a constant acceleration a, passes through points A, B, and C. Okay, let's say A is here, B is somewhere over here, C is somewhere over here. The time taken from A to B and B to C is 5 seconds. So this is 5 seconds, 5 seconds. The speed of the car at A is U. Okay. And the distance from AB is 55 meters and BC is 65 meters. Find the value of U and find the value of A. A is the acceleration on both parts of the journey. So the acceleration here is A, the acceleration here is A. Okay, so now we need U and we need A. We only have two parameters given to us, the time and the distance. We don't have U, we don't have A. Also, we don't have what's left, V. V bhi nahi pata. So now what do? We have two different journeys. We have the first journey AB and we have the second journey BC. What we'll do is we'll form two simultaneous equations and then we'll solve them to get the value of U and A. Now, the problem with the second part of the journey, BC, is that the U is not applied on this part of the journey because it has its own speed over here. It would be some other speed V. So if I form an equation using the parameters of BC only, I will not be able to use U in it. So instead, what I'll do is that the second part of the journey, I'll not consider BC to form the equation. I'll consider the entire journey from A to C. So from A to C, what do we know? This is A, this is C. So we know U is still U. We know the acceleration is still A. Time will be 10 seconds and distance will be 120 meters. In fact, yes, 120 meters. So now we'll get to use U and A in this equation as well. So instead of taking the distance BC, you should take the distance AC so that you get to use U in the equation. Okay, so let's form an equation at AB. Okay, so U is U, A is A, T is 5, and S is 55. So I need a formula that connects these. That will be S equals UT plus half AT square. 55 equals 5U plus half times A times 5 square. So 55 equals 5U plus half times 25 times A. Okay, that could be our equation number 1. But what I'll do is take LCM over here, get rid of the denominator. This becomes 10U plus 25A upon 2. So that's 110 equals 10U plus 25A. That could be the equation number 1. You could also divide both sides with 5. Just give me a second. All right, sorry. Okay, so I'm going to divide both sides with 5. So 110 divided by 5 is 22 equals 2u plus 5a. And if something has gone wrong, let me quickly double check. $55 into 2 is not 110. It is 110. अच्छा फिर मैंने इधर गलत किया, but never mind. This would be the equation number 1. Now let's form equation number 2 using the path AC. So at AC, we again have U, we have A, we have time, which is 10, and we have S, which is 120. Same equation, S equals UT plus half AT square. 120 equals 10U, sorry, yeah, 10U plus half times A times 10 square. So we get 120 equals 10U plus 100 upon 2 is 50A. Divide both sides with 10, so 12 equals U plus 5A. Okay, equation 2. Please solve these simultaneously and tell me what you get for A and U.
A is 0.4 and U is 10.
Yes. A would be 0.4 and U should be 10. Did others get the same answer?
Yes, ma'am.
Yes, ma'am.
You could use substitution or you could use elimination. Okay. Moving on. Question 30. A train starts from rest at station A and travels in a straight line to station B, where it comes to rest. So it starts from rest and ends at rest as well. The train moves with a constant acceleration of 0.025 meters per second for the first 200 seconds and with a constant speed for the next 2600 seconds, and finally with a constant deceleration of 0.0375 meters per second square. Find the total time taken for the train to travel from A to B. Okay, let me just try to write all the data down. Okay, So we know that it starts from station A, travels in a straight line to station B, starts at rest, starts from rest, and ends at rest as well. So this would be 0. The train moves with a constant acceleration of 0.025 for the first 600 seconds. So let's say this covers the first 600 seconds. So the time here would be 600 seconds. And the acceleration here is 0.025. That's the first part of the journey. For the first 600 seconds, and with the constant speed for the next 2600 seconds. Okay, so for the next part of the journey, the time is 2600 seconds and the speed is constant. Speed is constant. That means whatever is the speed over here is going to be the speed over here. It's going to be the same speed. Okay. And if speed is 0, if speed is constant, that means acceleration is 0. Also for constant speed, you just use speed is equals to distance over time. You don't use equations of motion. So speed is equals to distance over time. Or S is equals to Vt. Okay. And then for the third part of the journey, we know that, and finally with a constant deceleration of 0.0375, so negative 0.0375. All right, find the total time taken for the train to travel from A to B. All right, so we know the time in this part of the journey already, 600 seconds. We know the time in the second part of the journey as well, but we don't have the time in the third part of the journey. So for the third part, we know two parameters. We know the acceleration. We know the final speed V. We need one more value so that we can apply equations of motion and find T from there. Okay. Up T is question mark. But what can we find for this blue part of the journey that can help us in finding T? Okay. We should be able to find this speed, V, which is the same as this speed. So that means I'll go to the first part of the journey that was from A, that was the green part of the journey, and find its final speed and then use it at the last part of the journey. Okay, so for the first part of the journey, now we need V. So U is 0, T is 600, A is 0.025, V is what we need. So we need to use one of the equations of motion, which is going to be V equals U plus AT. So 0 plus 0.025 times 600. Okay. Now we're going to use that here. This becomes 15. And in the second part of the journey, the speed stays constant. So this will be 15 as well. But this is actually U for the third part of the journey. So now for the third part, U is 15, V is 0, and A is minus 0.0375. Okay. And time is question mark. So V equals U plus AT. 0 equals 15 minus 0.0375 times T. So find T from here. Should be 400
T is
seconds. Sorry, 400, right?
yes.
Okay, so T comes out to be 400 seconds, and that is we needed the total time. So the first part of the journey takes 600 seconds. The second part of the journey takes 2600 seconds, and the third part of the journey takes 400 seconds. So 600 plus 2600 plus 400. That is going to be 3600 seconds. Sketch the velocity time graph for the journey and find the distance AB. Okay, so velocity time graph has velocity on the y-axis. You must correctly label the graph. So velocity on the y-axis in meters per second. Time on the x-axis in seconds. The journey starts from speed 0. And then the speed becomes 15 in 600 seconds. So 15 in 600 seconds. 600 is, let's say, over here. So you draw a straight line from 0, 0 to 600, 50. Then the speed stays constant for the next 2600 seconds. So 2600 plus 600 is 3200. So you make a straight line till 3200 seconds, because 600 plus 2600 is 32. Okay. Next, in 400 seconds, the speed again becomes 0. So 400 would be 3400. Sorry, 3600. So now join this to this. Okay, that is going to be the velocity time graph. Then it says find the distance. How do we find distance from velocity time graph?
Area under the graph.
Yes, find the area. So distance is area, and this shape is a trapezium. Area of trapezium is height times half times height times sum of parallel sides. So half times sum of parallel side would be, the lower side is 3600, and the upper side, this is 2600 when you subtract 600 and 3200. Plus, we also know from here that the second part of the journey takes 2600 seconds times height, which is 15. What do we get here? 46,500. 46,500 kilometers. Part 3. The speed of the train T seconds after leaving A is 7.5. State the possible values of T. Okay. So 7.5 speed would be somewhere over here. So this is 7.5 somewhere over here. So we can see that at two values of time, you get the same speed here and here. So you have to find both those times that give you the same speed. Okay. We also know from the data that this acceleration for this part of the journey is 0.025 and acceleration or deceleration for this part of the journey is the acceleration is negative 0.0375. So we already know the slopes of these lines. Let's use that. The slope here, slope is the acceleration in the velocity time graph. So the acceleration here or the gradient here is 0.025 and the acceleration or deceleration or the gradient here is negative 0.0375. Okay, so gradient is rise over run. So for the first part, consider this part only. Okay, the gradient is going to stay the same because it's the same slope. Even in this small chunk of the slope is the same. So it's still 0.025. So gradient equals rise over run. Gradient is 0.025, rise is 7.5, and run is the time that we need, or x. X comes out to be 7.5 over 0.025, 300 seconds. So for the first time, the speed becomes 7.5 meters per second is at 600 seconds. So time or x equals 300 seconds. But again, it becomes 7.5 at this stage. So consider this chunk now. Again, gradient is going to stay the same, which is negative 0.0375. Gradient is still rise over run. So gradient is negative 0.0375 equals rise is 7.5. Run is x. We don't know what's the run here. We don't know what's the run in this part from here to here. We're going to find this run and subtract that from 3600. That will give us the answer of the second value of time. Okay. So, Acha, you don't have to consider the sign for rise over run, my bad. So do not consider this negative sign. Gradient is, if you're using rise over run, you always consider the positive gradient. So 0.0375 is the gradient. Find x 7.5 over 0.0375. That comes out to be 200. So x came out to be 200. So the run is 200. So subtract 200 from 3600. That gives us 3400. So the second time the speed becomes 7.5 is at 3400 seconds. question 14. All right. The diagram shows velocity time graph for the motion of two particles P and Q, which travel in the same direction along a straight line. P and Q both start at the same point X on the line, but Q starts to move T seconds later than P. So we can see from the graph, एक graph 0 से start हो रहा है और एक graph T से start हो रहा है. So that means the first graph is the graph for P, and the second graph is the graph for Q, which starts T seconds later. Each particle moves with the speed of 2.5 meters for first 20 seconds. Okay, so we can see that it's the first particle is starting at a speed of 2.5 meters per second and for 20 seconds. And the second particle also starts at 2.5 meters per second and stays at this speed for the next 20 seconds. So we don't know what T is. अगर T पता चल जाएगा तो उसमें फिर हम 20 ऐड कर देंगे तो we will also have this time. The speed of each particle changes instantaneously to 4. So soon after the 20 seconds, the speed instantaneously jumps to 4 and it stays at this speed. Similarly, this one also jumps to the speed of 4 after 20 seconds and then stays at this speed. Okay. Okay. The speed of each particle changes instantaneously to 4 meters per second after it has been moving for 20 seconds and the particle continues at this speed. Okay. Make a rough copy of the diagram and shade the region whose area represents the displacement of P from X at the instant where Q starts. Okay. So where does Q starts its motion? Q starts over here. So you have to shade the graph and show the displacement of the first particle at this point. So displacement is distance is the same as distance in this case because the object is not going back at any point. It's just moving straight ahead. So the distance and the displacement is going to be the same thing here. Okay. So what you have to do is shade this region. This is how much distance has been covered by the first particle P at the instant when Q begins to move. So shade this part. It is given that P has traveled 70 meters at the instant when Q starts. Find the value of T. So the area of the shaded region is कितने meters था 70 meters. Find the value of T. So distance is area again. So for part 2, area is equals to 70. The area of this shaded region, that is the distance covered, is 70. So we have to find T. So the first part, the first rectangle's area would be 2.5 into 20. So it has two parts. One of the area is 2.5 into 20 plus area of the other rectangle, the smaller rectangle, which I don't know yet. We don't know this area. Let's call it X equals 70. So the area of the second rectangle comes out to be 70 minus 2.5 into 20, that's also 20. Because area of the first part came out to be 50. This is 50 and total is 70. So definitely that part is 20. Now I'm going to do 20 equals length times width. So 20 equals length times width or base times height. Length is 4, width is, let's call it y, which comes out to be 5. So this distance is 5 units. That means t is 20 plus 5, 25. So t would be 20 plus 5, which is 25. Okay. So capital T is 25. So I'm writing 25 over here in the figure and then add 20 to it like we had discussed earlier. So this is 25 and this would be 45. Next it says, find the distance between P and Q when Q speed reaches 4 meters. Okay, so this is where Q speed reaches 4, right? So you need both the areas of the particles at this stage. So this would just be, Q is just this area. So for Q, part 3, for Q, it's just going to be 2.5 into 20, which is 50. Okay. And for P, we have to use all of this area, starting from here, till here, till here, all of this area. So we already know that this part of the area was what, 70? I think it was 70. Yes, 70. So this is already 70. So for P, it's going to be 70 plus this rectangle's area, which is going to be, the base is, or the width is 20 units and the height is 1.5. 1 times 1.5. So P's distance comes out to be 70 plus 20 into 1.5, which is 100. So the difference of the distance covered by the two would be 100 minus 50, which is 50 meters. गलत आंसर आ रहा है. The distance is 100 meters. Let me see मैंने क्या गलती की.
मैम आपने 1.5 लिया और 4 लेना था.
हाँ, 4 लेना था. पूरा एरिया लेना था. यस, ये पूरा लेना था ना, ये नहीं लिया मैंने, वो ऊपर वाला रेक्टेंगल लिया. और क्योंकि इसका एरिया हमें पहले ही पता था, पी के लिए हमने 50 निकाला हुआ था, तो ऊपर वाला एरिया आया था अभी 20 इंटू 1.5 विच वॉज 30. सो 70 और 30 और 50 ऐड करना था. 70, 30 एंड 50. सो ये बनता है 150. So we had to do 150 minus 50, which comes out to be 100. Okay. Part 4. sketch a single diagram showing displacement time graph for both P and Q with values shown on the t-axis at which the speed of either particle changes. Okay, so you have to draw distance time graph, displacement time graph. इस क्वेश्चन में like we've discussed already, distance और displacement बिल्कुल एक ही चीज है क्योंकि the particle P is just going forward and particle Q is also just going forward. There's no return journey. अगर ये वापस आ रहा होता तो चलो हम डिस्प्लेसमेंट की फिक्र करते कि अभी ये डिस्प्लेसमेंट है, डिस्टेंस कुछ और है, डिस्प्लेसमेंट कुछ और है. But since both the particles are going on a forward journey only, so displacement and distance is the same thing in this question. So just treat it as distance. Don't let the word displacement confuse you here. Okay. However, we're going to use the word displacement on the y-axis in meters, time in seconds, and they're saying that you have to show the displacement at all of these points: 0, then 20, then 25, and then 45. Because it says sketch single diagram showing the displacement time graph for both P and Q with values shown on the t-axis at which the speed of either particle changes. Okay, so let's start with P. P पहले 20 seconds में कितना distance cover करता है? वो total 70 था और ये I think ये 20 था. ये 20 था. This was 20. So then this was 50. This was 20. Okay. So for the first part, from 0 to 20 seconds, जो particle P है, that covers a distance of 50. So make a line of 50 over here and join these 2 points, 0, 0 and 20, 50. Okay. Then it further covers a distance of 20 meters in the next 5 seconds. So 50, 60, 70 हो गया ये total, and join these points, 25, 70 with 20, 50. And then it further covers a distance of 80. So बल्कि this block is going to stay the same. इस पूरे block का इकट्ठा area लेना चाहिए था. This rectangle is 50, 60, 70, 80, 90, 100. So it goes till 150. ये 70 को नहीं show करने की जरूरत. Straight line ऊपर लेके जाते हैं till 150. So let's say 150 is somewhere over here. 50 इधर और 150 इधर. Okay. So at 45 it should meet over here. तो ये line को सीधा stretch करके यहाँ तक ले गए. So you just need to show 2 lines. These are not parallel lines. थोड़ा सा bend आना चाहिए. Something like this. That's for P. पहले displacement 0 है. Then at 20 seconds, the displacement is 50. And then at 45 seconds, the displacement is 150. Okay, now for for Q, the displacement starts at 25 because Q starts to move at 25, but the displacement is 0 initially. So make a dot at, make the starting point at 25, and then it covers a distance of 50 meters at 45 seconds. So make a line like this. And then even beyond that, Q की movement दिखाई है, yes. Then Q is further moving after that. 45 seconds के बाद भी वो आगे move कर रहा है. ठीक है, so you draw a parallel line to the above line. इसके साथ एक parallel line आगे भी दिखा देनी चाहिए. ये दोनों parallel है और ये दोनों parallel. So that would be the displacement time graph for both P and Q.